parasitic draw. Now if you find your battery keeps going flat and you've got to keep charging it up to start the car, you may have a small current draining from the battery. So it's worth checking for this to see if there's any faults you can find in your car system. First thing you need to do is make sure you've got a good quality battery that should be reading about 12.6 volts. Such as this one, 12.69 volts, that's fine. If something's drawing current, you can measure voltage drop across the fuses. There'll be a small voltage attached to that. Beauty of this method is you don't have to take anything off the battery or disconnect it. You just have to go to the fuse box and use an ordinary voltmeter. Go into the car and switch all the electrical apparatus off, such as your door light and switch. Just put a screwdriver in and lock the lock. Then make sure you put a bit of tape over it so you don't accidentally shut the door and break the lock when you finish the job. If you've got an open bonnet indicator on your dash, you want to close that lock off as well. This is often very stiff, so you'll need a big strong bar, or in my case I'm just loosening the tension with the spring by releasing the spring, which I'll put back when I reset the lock. Put some tape on that as well. Open the fuse panel. On this car it's on the inside, on the side of the dash. There's also some fuses under the bonnet which I'll also test. With the meter turned to volts and use your sharp-ended test probes. If you look closely at the fuses, you can see there's access to little test points on the back of the fuse. These are for this exact purpose. Once you've got your test probes attached, test for voltage across each individual fuse. You should see no volts, which means that circuit isn't drawing any current. Then go on to the next one and methodically go through all the fuses on the board. And that's about it really. I'll just show you what happens when you find a fuse that's got some millivolts. 0.3 millivolts, that's the circuit for the instrument panel, which run small LCD displays showing the clock. So that will absorb a small amount of power. And when we look at a conversion chart, we can see that works out to about 17 or 18 milliamps. And I'll show you the relevance of that shortly. This fuse here is the interior light. So if I put my probes on, 0 millivolts, and if I turn the light on, we get a reading, 2.6 millivolts, which for a 10 amp fuse works out at 338 milliamps. The other method you can use is you have to go back to the battery and take either the positive lead off or the negative lead, preferably the negative lead, which will safeguard against electrical shorts from the positive side. So it's better to use the ground side. And all you're doing is connecting between the ground and the negative earth lead on the battery and turning your meter to amps. So you're measuring the current flow. Attach one lead to the earth lead or the ground. I could just clip mine on here, and the other lead to the negative terminal on the battery. For this I used a pair of mole grips and the pointed probe. Set your meter to milliamps. And I've got about 145 milliamps here, which is quite high. What you're looking for a resting milliamp leakage is about 50 milliamps, between 50 and 85 milliamps. Anything higher and something is using the current. But we need to do one thing, and that's wait a while. A lot of the electronic control modules will use some power and then eventually shut down with no use, to use their sort of standard minimum amount of power, or a better term would be to hibernate or to go into sleep mode, which they're designed to do. I waited about 30 to 60 minutes, or basically had my lunch, and when I came back it was about 113 milliamps, a bit on the high side. Then what I suggest you do is, if you can get your meter still attached to the battery, to point through the windscreen in close proximity to where your fuses are. In my case, I could just about do this, leaning it up against the bonnet. And now all you need to do is start pulling fuses and see a difference on the meter. And if we look again at the instrument cluster fuse number 1 here, which if you remember was 0.3 millivolts, you'd expect the milliamp reading to drop when you take the fuse out, which it does, but not by much. So I'm presuming the fault lies elsewhere. I continued with the whole of this board and didn't find any more significant current drop. Scratching my head here. So I'll have to investigate further. There are fuses in the battery cover box which I can have a look at, but I'll have to leave that for another day. Anyway, I hope this explains a couple of methods you could use to try and trace a fault in your car. Don't forget to reset the catch on your door and your bonnet. Thank you for watching, and look forward to seeing you again on the future video where I might just be able to solve this problem. Bye for now.